Good evening, professors. My name is Ahmed Mutawa. Thank you for attending our Thesis presentation. I hope you will all enjoy watching me and my colleagues, Ahmed Barakat, Ahmed Hassan, Lee Masah, present today. Today in Cairo, we have one important immense issue that 1 liter of water is much more expensive than gasoline. Therefore, it's stated that 1 liter of water is 1.25 more than gasoline. Therefore, we should all bear in mind that water is one vital agent, that we all should use it sensibly and wisely. Generally speaking, our project is all about the reuse of treated water in the irrigation system in New Cairo. First, I'll give you a brief introduction about our project. Secondly, the objective. Carrying on, we'll give you carrying on as scope 4. After that, the challenges, and then the data required with the design criteria, and then the methodology that will be used, and then the work time schedule, and finally the references. It's clear that public infrastructure is one of the public infrastructure investment is one of the primary means to implement the strategy of regional growth, thus providing infrastructure provides services that support economic growth, thus increasing the productivity of labor and capital, and then reducing the cost of production, and thus increasing the profitability, the production, income, and employment. New Cairo irrigation system. New Cairo irrigation system receives treated water from the tertiary wastewater treatment plant. It's located on the Cairo Sofna Road. It's approximately 400 meters above sea level. Furthermore, wastewater treatment plant pumps around 40 to 45,000 cubic meters daily with a maximum capacity of 100,000 cubic meters daily. The irrigation network mainly supplies universities such as the CENG and other universities, the resorts, public green areas, and golf areas. A lot of problems have been raised in the irrigation network. Excess pressure failures in some loads, which causes excess water flows. Our objective is to design the system. Our objective is to design the irrigation system with all its components. To design the system with all its components and taking into account the fluctuation in demands, the balancing tank, and the design of the pumping station. We will use different scenarios until we reach the most economic and feasible and safe system. My colleague Ahmed Barakat will continue the rest.
Our scope of work is mainly designing the irrigation system of New Cairo. We will start by calculating the irrigation water demands through estimating areas, green areas in New Cairo. Then we will design the irrigation pipe network to obtain pipe diameters, material strength, and the pipe layout. And we will design the pumping station hydraulically to find the number of pumps needed, the type of pump, and the pumping head. And this is the real pumping station in the water treatment plant. We will be also designing a balancing tank, hydraulically and structurally. The balancing tank has a capacity of half day or a full day of supply, of daily supply. This is the New Cairo plan. The water treatment plant is located over here. This is the New Cairo, and the ring road is coming from here, and this is the north direction. This is a Google Earth view. We will use it to calculate the green area in Tagamma. It's mainly in Atomea Heights and the golf course and universities and public green areas. The wastewater treatment plant, we have also an AutoCAD view, an AutoCAD plan, and a Google Maps plan. This is in between the white circle is the location of the balancing tank. It does not exist nowadays. It's still under construction, and then the red circle is the pumping station and the chlorination tank. In a normal operation, the pressure is lost through the pipes in friction, so the pressure does not accumulate in the pipe. However, in low demands, the pressure accumulates in the pipe. This may cause for us a challenge while designing. We have to design for normal operation and low operation.
about the data required for our project, we need first begin with the drawings we need. The physical plan of New Cairo and the topography of New Cairo, so we can lay out the pipes, valves, and pumping station according to the green areas and the roads. Also to find the elevation of the pipes and nodes. There is a group of aspects which will affect our calculating our water demand, as the water demand is the most important part in the design criteria of our project. So we are trying to approach an estimation as accurate as possible. The aspects are as follow: the different demands in the different seasons. Also the type of plant that we will irrigate, the type of soil, so we can assume the ratio of runoff and drainage. Also the daily fluctuating demand, we want to calculate it or to find the profile by using a flow meter which will be authorized from AFC. This flow meter will be connected to the outlet pipe from the wastewater treatment plant to find the profile. We will need the elevation of the treatment plant so we can find the type of the balancing tank we will design. Also the pumping head of the pumps. We will also need a soil report so we can find the characteristics of the soil to avoid any settlement to our structures. This is a picture of why the soil is important. The runoff and percolation. Also, this is a picture for flow meter. There are many design criteria. As I said before, the water demand is one of the most important design criteria. The Egyptian code will retrieve from it many limits that related to our project. There is a way in addition to calculate the losses in the pipes. Pipe safe velocity. Also, we have to make sure the velocity is in the safe limits, because if it exceeds the limit, then abrasion will occur in the inner walls of the pipes. We will choose a maximum pressure for all our pipes. For example, the current network has a 10 bar maximum pressure. Also, we will look for the local market pipe diameters, which will affect our pipe selection. And now we move for the
Here are the programs that we will be working with. The main program that we will use is AutoCAD in the design of the network. We will also use AutoCAD to read soft copies of available plans. And we will use Google Earth to calculate the green areas and get the elevation of the roads, and it will help us in laying out the network. We'll use Excel to perform calculations and functions required. And we will use SAP in the structural design of the balancing plan. Due to the current circumstances in the New Cairo campus, our activities have been delayed and we're unable to come up with an exact time schedule. However, our activities will be mainly the design of the pipe network, the balancing tank and the pump station, which will be ongoing activities till the end of the semester. And we are hopeful that by next week we're able to calculate the demand and use Google Earth to locate the pipe locations. Here are the references that we used. Thank you.
Actually, I just wanted to ask you, did you consider in the design, I think you have to consider, is it sprinkler or drip irrigation that you are going to provide water to?
It's mainly sprinkler irrigation because it's for grass and.
So you investigate?
Yes.
Okay, and is the water that you are going to use, it's reuse water, all of it is going to come from the treatment plant?
Yes.
Is going to be sufficient?
The capacity of the treatment plant is 100 meter cube per day, but we don't know it's sufficient because we didn't calculate the green areas till now.
You have to check this. Okay? And also the pumping stations, maybe you are going to use more than one pumping station. Okay, because of the head, maybe the head is going to be low. So because of that also you have to consider that and the locations of those pumping stations.
The main, we will locate the pumping station inside the wastewater treatment.
Exactly. This is the main one that is going to provide the water to the community.
Yes.
But did you consider putting pumping station? Of course, you are going to design for the pressures and you are going to calculate the pressures. If you need, you have to put another.
Inside the New Cairo?
Of course, we want to avoid this because it is not going to be this good design. So you have to take this into consideration and check the pressures and so on.
Yeah, for a good design, only one pump station should be used.
But if you need more than that, you have to put it. Because we don't want to interfere with the community, take space and things like that. So you have to check. Do we need another pumping station or not? We need a pumping station. But you can maybe manipulate your design in such a way that you don't need other pumping stations.
Okay. Are you going to consider transient analysis, water hammer, and sudden failure of for electricity, sudden outage, and pumping on a closed valve and stuff like that?
We will take it into consideration.
I think it's important to do at least a quick transient analysis to make sure that the pipes are going not only to hold the static load but also the transient load. When you say you're going to use Google to see where are the irrigated areas, I think it's much better if you can get hold of some urban planning graphics or drawings, because Google can really be, because you're designing in the future, not everything is shown in Google. When you look at Google, if you don't have a professional one, probably you're going to get a picture which is dated a few months or even a year in the past. It might be misleading a little bit.
We'll have an attested drawing soon.
And
We used Google Earth because the plan we had was from 2006. So we had to.
it's a little better if you can get hold of an urban plan and try to assess your need for the future until the end of the design period. Last question: are you considering water quality at all, or it's mainly hydraulic design?
It's mainly.
Maybe it's not my specialty, but I will pose this question. Besides the conventional losses in the pipes and pump, all the conventional losses that we decodified, did you think of a methodology to estimate the losses resulted from the misuse by the end user? For example, my understanding is not all the irrigation is going to happen through sprinkler, automatic sprinkler system. There will be human factor involved, I believe, in some of the end user irrigation. So, is there any model to estimate that, whether it is a national here in Egypt or international model that actually include the human factor in your future design?
We don't have an exact model. However, the balancing tank will help us in this aspect, because nowadays this design that's in the streets have a problem of coordination between the users and the wastewater treatment plant itself. So mainly we will store the water inside the balancing tank until the users need it. Or we will supply the water throughout the day in the concentrate, but we will need a balancing tank at the users, not at the treatment plant.
But the overall losses in the system?
Will be mainly the normal friction losses and minor losses.
Just to ask again a question for clarification. You mentioned because of the delay in the new campus circumstances, something like that. Well, let me just ask you, if you have all these softwares available and you have the maps, and do you need a new campus for anything? No,
You need to get the programs.
okay, so it's mainly for the software.
And you need to meet the assistants.
No, we will bring them to you wherever you are. I guess what I'm saying, you don't need a new campus physically for anything. Okay, just.
Thank you very much.